I forget his actual name. His website is Calculus Maximus. I think it actually has his name on there somewhere. No, well, actually, it might be Max. I don't know. I think his last name is Corpus, I think. I don't know his first name. I might be wrong. Dave or something like that? I think it's, I don't know. I saw, ooh, hey, look, the AP exam is 69 days, 15 hours, 51 minutes, and 48.765 seconds.
Why you're adding on my anxiety?
Well, you're the one that asked me his name, so I came on here.
No, like...
I think it's Dave. I think it's Dave Corpus. I might be wrong, though.
Dave? That was
it's
like...
hosted by Jeremy
That was
Davenport.
like big contrast.
Oh, Thomas!
Wow.
No! Steve.
Tomas.
Okay, now I don't know, because I think that's just family, so it could just be his family. I don't know. His last name is Corpus, though. Anyway, coming back. So it's his answer key. I'm sorry, it's not gorgeous, but it works. So yesterday, we started our way through number 6, right? You guys have done 3 and 5 with me. Number 4 is one you need to do on your own. We got to number 6, and I started. My advice for the time that we have right now, well, I don't know. It's kind of up to you. In period 1, we ended up going to number 7 because we didn't do it yesterday. With you guys, we did start working through number 7, but we didn't finish. But we didn't work through number 6, and I had you guys go check out the video. I do want to reward those of you guys that have gotten started and went to the answer key to check and you've gotten stuck. I would love to go see where you are stuck, and then I think the rest of the class can kind of benefit from that as far as the questions you might have. But I would love to finish one of these FRQs, either 6 or 7. So I want you guys to take a second, maybe talk in your groups, maybe think about individually. If I was to finish one of these FRQs, I'm getting Dean's video ready to go. If I was to finish one of them, which one would you want? If I was to finish one of them, which one would you want me to finish? Real quick, ready, set, 30-second discussion. Figure out which one I'm going to do, 6 or 7, before I go to homework questions. People who are working on the packet, where they've gotten stuck. It's not due until tomorrow. Technically turning it in end of class.
What if we do number 6, but instead of a question on number 7?
Well, I'll go there. I just won't do necessarily the whole thing. Does that make sense? I would love to finish like one all the way. All right, talk about new groups. About 15 more seconds. Which one we're going to do? Dean, I think I have your flash drive ready to go. Calculators up.
Look at 7. 7 is so hard.
7? Okay. Calculators out. Can you guys put E and L as Y1 and Y2? We need to make sure we can use our calculators. We need to review the content and make sure that we're trying to track, and we are trying not to fall asleep. And we are, I guess, giving me senior Bible textbooks too. I have a whole collection in there. Thank you for that. That's not really most of you guys, but anyway. All right, so Y1, Y2. You guys getting this in? You have your E and you have your L. You have your E and you have your L. Whenever you have an FRQ in calculus, and whenever they give you a function, you almost always want to put the entire thing into your calculator. This time they give us 2 separate ones. So you want to throw those into your calculator. And yesterday, we figured out how to do part A, so if you didn't go back and finish part A, once you have this function in your integral, you should be plugging in from the home screen the definite integral from 9 to 17 of, wait a minute, why didn't I write the whole thing? They gave it to me. Why not write the 15,600 over t squared minus 2014? Why not write all that? It's in your calculator, number 1. Number 2, didn't they give it a name? And number 3, wouldn't it take more time? Yes. And number 4, couldn't I possibly rewrite it wrong?
Yeah.
And here's a quick note that everyone needs to know about the AP FRQs or free responses. Even if you get the answer right, if you wrote something wrong, they have to take off a point because you need your solution to be seamless, to be perfect. Doesn't mean it has to be the best one in the whole entire world. It just can't have something wrong.
It just can't be
Which means you can't leave out the DT. Are you looking at your work? You can't leave out the DT. I'm not saying they'll take away all points, but any error that they see take off at least one.
What if they don't?
Don't know what ifs. We just have to write it right. Which means if you wrote this down here, even if you put it in your calculator right and got the right answer, and you wrote 1,560 instead of 15,600, you just lost one of your maybe 1 or 2 points that this whole question was worth. Does that make sense?
Ooh.
So we name it E. We name it L. We try to write as little as possible when solving. Now, have you guys thrown it in your calculator? Do you know how to use your calculator? How do I get the integral? Real quick. Alpha, window, number 4. Yeah? Cool. And then we put in 9 to 17 as our bounds. How do we get the function without having to type it in and waste time and maybe make it wrong? Alpha, trace, it's in our y1, right? For our e. Then we can go over dx. Dun, 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 6004. Now wait a minute. This is AP Calculus. We always keep 3 decimal places, except when they say round to the nearest person. Yeah, they say round to the nearest person. I do it. 6004. Good. If you guys are bored, you may be getting out your Google Classroom, opening up the answer key, and checking what you've already done. But most of us don't have much done in this packet, despite me assigning it Friday. Now, if we were to come down here, the one that we started yesterday, and if we were to plug in the 6004, we would actually be wrong. The idea is right, but we would be wrong. If we were to go look at the answer key, which I think I have in a different tab, and I can't reach it until I come to my computer. If we were to check, number 7, part B, how do you guys see him making the expression for $15 from when the park opens to when it to 5, and then $11 from 5 to closing? Does he use the 6,004?
No.
He uses the integral. Why?
Because we need it.
Because that's how many people are
I'm not
entering the
rounding until the final answer. So I do need 6,004 here, but I don't want the rounded form. I don't want the approximate form. I want the exact form. In calculus, unlike sig figs and other places where it's like, no, just do this the whole time. Always whole number, or always 3 decimal places. No, not in calculus. If we are using a previous value to find a future value, we always do the full, the exact as we can form, not the rounded. We can answer because they told us to round, but not here. So if you guys are trying to make sure you can make it match, make sure you can use your calculator. But remember, for part B, we're trying to take the from 9 to 17, how many people, not the approximate, but the actual. So I'm going to erase this little arrow. I don't want to do that. We're not going to bring the 6,004 down. We're going to bring the integral down. Choop, 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 choop.
Wrong.
And then somebody had a question also. Bloop, bloop. There we go. So it's not that the idea was wrong. The idea was perfect. How many people have entered and they paid this price? How many people have entered after that and they paid this price? But I skipped over someone's question. Joe, was it you or Matthew? Was it you? It was someone. Joe, what was your question?
I was like, you could get like non-whole number from the 2 equation. Like you obviously can like sell half of the ticket. So.
Oh yeah, but also realize this isn't the literal what happened. This is the mathematical projection.
Okay.
And mathematical projections are going to have decimals even though people are whole. Does that make sense?
Mm-hmm.
Yeah. So as you guys plug and chug, are you getting the correct answer of, we talked about this one yesterday, 104,048. Now actually, I don't like his answer, and let me show you why. I like the 104,000. I like the 48, but I think he should have put the cents in. Can anybody figure out why I think he should have put the cents in? What did the question say?
How many dollars?
Okay. So do you understand why he rounded to the nearest dollar? Okay, fine. It says how many dollars were collected. So he rounded to the nearest dollars. But in context of what I have seen in the actual AP, if they want it rounded to the nearest whole number, they will tell you. Otherwise, don't. So, for our future, the AP is coming. If they want the nearest whole number, they better tell me. And if they don't tell me, it's always 3 decimal places. Well, money. Okay, money. We round to. Okay, but we're going to round to those 2 decimal places. They did not say round to the nearest whole dollar. So I'm not going to. I'm going to do, 0.17 and 17 cents. Now, we understand why he rounded to the nearest whole dollar. I get that, but if the AP doesn't explicitly say it, like it did in letter A, don't do it. Okay. Double check. Is that all they want? How many dollars were collected? Got it. Okay. So now coming down. We have not talked about C or D, true?
Mm-hmm.
So let's review really quickly what we have. We have 2 rates. E, how fast are you coming in people per hour? L, how fast are you leaving in people per hour? We have the park being open from 9 and no customers being in the park at 9. They start entering at 9 until 23. 23 is when the park is closed and they start shuttling out. Okay, coming down here. Part C says, guess what? There's somebody else. Who's the new somebody? H. Now, as you keep reading through the question, keep reading through H. What are we supposed to be doing?
Find the value of H prime at 11.
You're
That's
right.
the problem though.
Okay, so H prime, we're taking a derivative of H, who's up here at 17, and we're talking about who is this and who is that. Now, H of 17, oh, didn't they just tell us that?
Yeah.
Okay, they told us H of 17. But what is it? Yeah, we're supposed to be explaining this.
How much people in the?
How many people? How did you know that?
Because.
Is
Wow.
it rates inside and you're coming out to amount?
Yeah.
So people per
Because
hour is
you're like
coming out
in
to
minus
people.
out. Because the equation is like in subtract out, so it should be how many people sit inside the car.
Yes.
Do you guys agree with Joe? How many people are
In the park at
H
that
prime is
specific
how many
time.
people are changing.
The integral of this is how many people have come in.
Integral.
Integral of L is how many people have left. So H is how many people are
In the
here,
park.
still there. Yeah.
Here.
So we can say at 5 p.m. Wait, what's 5 p.m. again? 17 hours for midnight. Good military time. At 5 p.m. That was earlier in the problem. At 5 p.m. There are 3,725. They gave me that number, right?
Yeah.
People in the park. And that amount is at a rate of. Why am I being snazzy? Why am I talking about a rate all of a sudden? Because H prime of 17 is something they want me to find. It isn't the derivative of a quantity, the rate of that. Wait, why did I leave a blank? We need to find it, and we'll see if that's what fills the blank or not. At a rate of, wait a minute, I think that's another blank. You guys should be thinking of, how on earth are we going to find H prime of 17?
Just
17. Well, that's how you find H of 17. I
Just
think that's
try
where
it.
this number's
Just
coming
derive
from.
it.
Okay, just derive. I love that you said it. I'm curious if you know how to do it.
It's complicated, but it's not
H
impossible.
of t is the integral from 9 to t of e of x minus L of x dx. Has anybody wondered why that's a t and that's an x?
Oh, we have that in the test, like x squared and then yeah.
What is that? What is it when you have an a to a u of a something with a t and you're trying to FTC part 2?
Yeah.
I want to find h prime. Isn't h prime the derivative of h. But if I'm deriving h, don't I have to derive that guy?
Oh.
How do I derive an integral?
E.
I plug it in, right?
Yeah.
The derivative from a to u of a function is f of plug it in, which is going to be e of t minus l of t. And what is the t I'm trying to do all of this at? H prime of 17 says plug in. How do I use my calculator to do that? Why not just plug it in? Right?
Yeah.
Plug it in.
When did you show that you ever found the integral of?
We don't need to. Because we could have done this one, which was h of 17. They did ask for the meaning of it, but they already told me the answer. So if I wanted to find h of 17, I could have done the integral, and that would have been 3,724 point something. But they already gave me that answer, so I didn't go looking for h of 17. I'm looking for what they told me to find, which is h prime. H prime says take the derivative. Take the derivative says, well, if this is going to anti-derive, then this is going to derive. Don't they kind of just cancel each other out? So I don't actually have to figure out how to anti-derive them. They're undoing each other. FTC part 2 says don't anti-derive and derive. Just use me. Use FTC part 2 to say the derivative of any integral from any constant to any variable is this integrand with this plugged in times u prime, but what's the derivative of t? What's the derivative of t? 1. Times u prime is 1. So then u prime is 1 doesn't change anything. So all I have to do is just plug in 17 and plug in 17.
Exactly.
So at a rate of, and I can put a little like, hey, that's e of 17 minus l of 17. And what's e of 17 minus l of 17? I don't know, but my calculator does.
Mode.
If you use the really snazzy fraction bar, which keeps you honest, keeps you safe, Kylo Dad this morning's like, I plugged it in right, but he used a division sign and didn't put parentheses, and he was all up. If you use the cool fraction bar, it's going to give you fractions. Why is that bad?
For preference.
I want decimals, but the cool thing is this little f to d, d to f thing will take what I have and give me what I want. Oh. Negative? Huh?
Oh,
Ooh.
So what am I going to fill in the blank with? Decreasing. Woo! At a rate of 380 points. Does it say nearest whole number? No. It says h of 17, but it doesn't tell me h prime of 17.
It is people, but.
So it does say people, but it doesn't say for me to round it, so I'm not going to. 0.281.
So you just slice somebody's head off.
Oh, I did not. This is a mathematical projection. 281.
You can't afford to wait in person.
And then it's a mathematical projection. So
I mean, Star Wars,
Wait,
you have
do you have to
0.28%,
do
like
or you
percent
already
every
decrease?
all the time. So.
I don't put negative because I put decreasing. Good. And why am I putting decreasing? Because they told me to explain.
Hannibal.
So I'm not just giving the rate at how fast in people per hour, but I'm saying I know it's decreasing at that rate. What's decreasing? Oh, the number of people in the park. Oh, I just showed my full comprehension of the entire question. Nice.
How did you even have enough to like make that?
Well, part of it is a lot of
That was
problems. And part of it is, remember how in the Forever card, I mentioned about how integration as net change is really good for motion, but for the AP, it's best for any amount changing at any rate. I've seen a lot of free response questions that have a lot of explain what this means in context of the problem. And so I know that when they're talking about rate, they want me, when they're talking about a prime, they want me to say, I know it's a rate. I know that means it's a how fast. And I know the positive means increasing, the negative means decreasing. So I'm trying to kind of start sending that your way. Does that make sense? I think we answered our questions. Did we get in the answer for h prime of 17? Yes. Did we get in the units? Yes. Did we get in the explanation of what that guy is and what that guy is? Yes. I'm going to zoom in. I just wanted you guys to see and make sure that you knew why I was doing E of 17 minus L of 17. So let's go ahead and zoom in. What's really nice about AP Calc questions and exams, not that they're easy necessarily, but they are fairly formulaic in the sense that the big ideas will always be the big ideas in the problems. It's not like AP Bio where it's like, oh, you didn't get to that chapter? Oh, guess what? A huge question was on this random topic that you might not have learned.
What's the issue?
That was just last year. Make sure you can cover that topic.
And for the big
But when any of the sciences, they can like ask you a random question about some topic that's like, well, we didn't, or even AP history, right? APUSH? Or
Isn't
math?
math a part
Can't
of
they
that?
randomly like go and say like, oh hey, let's talk a lot about this when you had to learn all of these years of history and all this like yeah. Math, it's like well, we have limits, we have rates, and we have amounts, and then I mean in there is like derivatives and integrals, but those are our big ideas. They can give us bananas, they can give us snow, they can give us water in a tank, they can give us oil in an ocean, but it's still amount, rate. Figure out how to use derivatives and integrals to help us.
People in the amusement.
At what time T does the model, ooh, this is a mathematical model, so no people's arms are getting chopped off.
That's good.
At what time, I know, at what time T, just trying to reassure you, does the model, all of this mathematical prediction, predict, oh, there you go, that the number of the people in the park is a
Maximum.
maximum.
Oh, there we go.
The people in the park is a max. Right.
Either you can find there's a
Wait a minute. Number of people in the park. If I didn't know who H was before, could I have maybe known by just reading the problem after? H was the number of people in the park. If I had kept reading, maybe I would have figured that out. Anyway, so what do they want? Mathematically, they want the maximum of H. Now we have to go back to first semester because relative and absolute maximums and minimums were back then. What do we know about relative and absolute extrema? What do we look at? Well, I mean, if this was pre-cal, they would give us a function for the number of people in the park and we'd graph it. We'd say, hey, it's the highest. Boop, there's the max. But what equations do they give us? Is it the people in the park? It's the how fast of the people in the park. Well, we can't graph the how fast. Well, we can, but if we graph the how fast, we're graphing the derivative. Can we find extrema from graphs of derivatives? You can be sad about it, but the answer is yes. Haven't we looked at graphs of derivatives and tried to think of the original?
Yeah.
So to find the max of H, does anybody think critical numbers? Does anybody think testing the signs? Let me give you a hint. Could be just, well, Matthew, that's great that we could just plug in, but the problem is we wouldn't be looking at the number of people in the park. We'd be looking at how fast it's changing. So we have to be able to look at the derivative and know the maximum of the people.
find the point.
Find what point?
Maximum.
No, we can't graph the how fast and find when is it increasing the fastest. That's not necessary.
No, I mean H, not H.
Well, who's H's equation? Exactly. Do you want to anti-derive both of those?
Not really.
Exactly. Neither do I. So we don't want to get H's actual equation because we would have to anti-derive the top and the bottom. We'd have to maybe complete the square or factor and do partial fractions, and it would be a lot of work. Or we could just look at the derivative instead. Don't maximums occur at critical numbers
Exactly.
where H prime changes from positive to
To negative or negative. No.
That'd be minimum. Yeah,
Only
yeah.
this way.
Then H is going from increasing to decreasing, but I don't know H. I don't want to find H. I don't want to anti-derive.
But we can know when like actually plunges.
Now, careful. Absolute extrema, we have to also think about for absolute. We have to also think about
Relative.
endpoints. Yeah,
And
the first
absolute.
one's just relative. Absolute, we also have to think about endpoints. So we have to think about the whole interval from 9 to 23. But the cool thing is, I can think about 9 to 23 in my calculator. I just make my window 9 to 23. And let me give you a hint. You should also make the y's like negative 1,000 to 1,000. Poor guy, it's a struggle. But we're playing with our calculator. So 9 to 23. Y's negative 1,000 to 1,000. You could plug in like what is E of 9, what is L of 9. Just make sure your y's go high enough. That's kind of what I did in period 1. Their video kind of broke down because the microphone wasn't working. Sadly. But that's okay. I think we're going to get more work done because we started number 7 yesterday. They just started it today. They worked hard on number 6 yesterday, which is on the video still from yesterday. When you graph this, we could graph E and we could graph L. We could graph E and we could graph L. There's E. That's how fast people are. Oh, they're going in fast, and then they're going in slower and slower and slower until the park closes. Wait, why is it graphing on 3? Hey, excuse you. I only wanted you to graph 2 of them. Thank you. Boop, boop, ba-doop.
Just get rid of it.
How fast they're coming in? How fast they're going out? Wait, why are so many people leaving more over here?
Because it's late.
It's late. The families will leave and have to go to bed, right? Okay.
They can always go
But
in
then
their
it's like,
car.
oh no, let's stay till the end. We don't want to leave anymore. So then fewer and fewer and fewer. And then you have to kick them out. Wait, why are so many people entering? Oh, because it's the beginning of the day and then fewer and fewer. Okay.
Makes sense.
But here's the question. If you're just looking at the E, how fast, and the L, how fast, how do we know when the number of people in the park are the highest?
We don't.
Would
Or
they intersect?
intersection.
Huh.
I don't think.
The red one.
Let's map H
Doesn't
equals
H-
T.
Doesn't H need both of them?
Exactly.
So wouldn't H, or wasn't H prime both of them?
Yes.
So could we graph them separately? Yes. Could we also just say, nah, let's just graph them together? See? E minus L.
How'd you
Now what?
toggle? Wait, let's see.
This is H prime because H prime is E of t minus L of t, which I did by doing, ready? Remember? My y1 minus my y2, this guy minus that guy. And when I graphed it, aren't I looking for critical numbers
Wait, is
which
this
are
rate?
zeros?
Yeah.
Is this rate?
Mm-hmm.
So it
If
should
E
be
is
the
rate, L
intersection.
is rate.
So it should be the intercept point because
If I graph them separately, but I graph them together of E minus L, so that would be the 0,
Yeah.
which is the same thing as the intersection.
when it start to like
So Joe's
Going
saying,
out.
yeah, it's people are going in faster than they're going out, but then all of a sudden, they're going out faster than they're coming in. So the number of people in the park are increasing, and then the number of people in the park are decreasing.
decreasing.
You could think of it that way with the two separate
That's
graphs.
the area of the thing.
Or you could, and to be honest, to think of it that way, you'd have to get a good picture to see the intersection, which means you would have had to have figured out the 1,000. The nice thing is, if you're doing it the other way, isn't this always going to be at the 0, which is right here?
Yeah.
I won't have to go looking for the intersection. So I'm going to go ahead and go find the 0. What is the 0? The 0 is the critical number. And isn't the critical number where possible extrema occur? So I can go ahead and go a little bit before the 0. I can go a little bit after the 0. 15.794. What do they actually want? 15.794 is the time of my critical number. Am I making a sign chart? You bet I am. No, you don't have to. I'm just showing you the work in the sign chart. So I have H prime up top. I have H down bottom. Hey, isn't H prime the guy I just graphed? It's the rate. Where? Oh. Here, we'll just- Still look okay. So we we have H prime and we have H. If we're looking at H prime, remember H is the number of people in the park. H prime is the rate at which. H prime is what we're looking at, which is E minus L. Do you see how H prime is positive before and negative after? Or if we looked at those graphs, the people entering, it was faster than or people were entering faster than people were leaving. So the number of people in the park was growing, and then the number of people in the park was shrinking. The cool thing is, I don't even just know my critical number. I also can see the absolute extrema. So here's how I would write it. At t equals 15.794 hours past midnight, what am I trying to do? Stroke their ego and say, oh, you did such a good job making this problem. I'm going to use your words. Yeah, hours past midnight is what they said. Hours past midnight. The number of people in the park I'm not writing out the whole thing because my marker is kind of fat and my space on my page is kind of slim. The number of people in the park is a maximum since
Begin to decrease.
H prime equals 0 at this point. Remember, it has to be a critical number. You could also have said E of t equals L of t at this point. You could have also stated the intersection. Either way works.
Good.
At this point, and is, who is, H prime is. He's my noun. Ooh, gotta think grammar. And is strictly, oh, I don't know how that just happened. I don't know. And is strictly positive before and negative after proving this time is an absolute. The time is not an absolute max, sorry. This time is the location of the absolute max. Now we have to double check what they actually asked for. Did they just ask for time or did they ask for how many people? Just time. If they asked for how many people, we have to actually plug in. Now I went ahead and justified because this practically always needs a justification. And they will explicitly state justify. But also in showing our work needs to show that we have deduced, we have figured out the actual absolute extrema and not just the relative. Sadly, the sign chart kind of does give all the information, but they completely ignore any sign chart that is ever written. They only look at the words, which is a struggle. Well, if they see the sign chart, if something is written wrong, they just take off points for something wrong. But they won't give you any positive points for a sign chart. It has to be written in words. So it's technically showing our work more than anything. Anything that you cross out on the AP, they are not allowed to look at all. Anything you cross out on the AP, they are not allowed to look at all. Which means some of you guys on your test, when you have the right answer and you cross it out and put something else, I'm technically not supposed to give you anything for it.
Yeah, can you cross out the question?
And then you get no positive points for it, so it's you give me a 0. Well,
That's a big brain move.
You want
to thought you're in this class.
the AP guys don't give you negative points. If they're in a question and they're grading your work, they will give you the positive points, but then they have to start taking them away for the mistakes that you showed.
Ooh.
Does that make sense?
How much point you're getting taken away if you made that mistake?
It's however many mistakes you make. So if the question's worth 2 points and you made 2 mistakes, they're worth your 2 points.
What?
Well, then don't make the mistakes.
What if I just write?
Oh dear. I said don't make the mistakes. I'm serious. Those of you guys that were working in the packet, where did you get stuck? I want to reward you. Tony is ready. Where am I going?
Number 10 letters.
Number 10, letter C. You guys want to benefit from Tony working ahead? Oh yeah, traffic engineers.
We're all leech.
Okay,
We're all leech.
remember? Rate. What's changing?
Cars per hour.
Yeah, you see it, right?
Yeah.
What's happening
Almost
now? I don't know. Cars
40.
turning left. What cars? These cars. You just gotta kind of go find it. Think SAT, reading comprehension.
Automobiles.
Automobiles are cars. So
Not necessary.
we have, in this context, the problem we're looking at cars
I knew.
specifically. Cars per hour, cars turning left at an intersection in Thomasville, Oregon, whatever. We have a function, true? We have a time interval, 0 to 18. And then we have a graph of L, who is a rate. If I were you, I would label this rate so that your brain remembers rate and doesn't start accidentally thinking amount. Now, Tony is specifically asking us to go pop down to letter C. Traffic engineers will install a signal if there is any 2-hour time interval during which the product, I see some words that I might need to make into math. The product, good, of the total number of cars turning left, which we haven't thought about yet as a class, but we will in just a second, and the total number of oncoming cars is greater than 200,000. In every 2-hour time interval, 500 oncoming cars travel straight through. Wait a minute. So that's 500? 500 oncoming cars travel straight through the intersection. Oh, okay. So that's 500. They gave me that. Well, that's nice. I can divide by 5, but I need to talk about this whole cars turning left thing. Wait a minute. What was L measuring? How fast cars are turning left, not how many. So how do we go from how fast to how many? We integrate. And what are we integrating starting from?
You're starting from A.
We're starting from something and then like 2
8
hours
plus 2.
past something. I don't know where. Well, I mean, up there it's 0 to 18, but they're saying, is there any 2-hour time interval? Well, I start somewhere and then I go 2 hours later from somewhere of my L of TDT. Because it's 2 hours later, not at A plus 2. Sorry, maybe I should have done B and B plus 2. What am I trying to show? I need some place, or I need to find if there is some place where there's 2 hours, like maybe it's 0 to 2, or 2 to 4, or 5 to 7, or 11 to 13. Are there 2 hours where this multiplication will work? Now, Matthew, you already said, well, hold on, we're good algebraic students. If we have a 500 and a 200,000, what can we do? Okay, so we're looking for, is there some sort of 2-hour interval where the area under this curve, is higher than, is greater than, take away 2 zeros, you would do this in your calculator, right? And we would get 400. Nope. Did I write that wrong? 4,000. Because 500 and 400. Oh, 1, 2, 3, 4. Oh, 20. Got it.
What is that? When you're doing algebra, you have to switch the sign after you.
That's when you multiply or divide by a negative number. Multiply or divide by a negative number. Now, can we go back to see what this top thing was? Doesn't this show me L? It shows me the rate. And don't we know that definite integrals are area?
Mm-hmm.
So would I want to go looking at 0 to 2 to find if this is like area that will make this good? No, because there are barely any cars turning left. Look at that. But why don't we go to the big part? Hey, where's the big part? Find me what 2 hours? Find me 2-hour interval in there. What do you think? Like 13 to 15, 14 to 16?
13 and 14.
Okay, 13 to 15, 14 to 16. Either way, we just need to know if it works. Yeah. So let's just grab out our nifty-difty handy-dandy calculator. I'm only doing this one calculation, so I'm not going to ruin my Y1, Y2 for it necessarily. I'm just going to go on my home screen. Now, if I had been doing this whole problem, I probably would have plugged it in. Making sure that no pre-cal kids have borrowed your calculator. You're still in radian mode. Why am I making sure? Because there's a sign, right? This has trig. So I'm going to go ahead and go get my nifty-difty integral. I'm going to plug in. Well, I'm going to do both just because you guys said both, and let's see if it made a difference. 13 to 15, 14 to 16, 13.5 to 15.5. I'm going to throw in my 60 square root of t, which, whatever. The x button is faster to get to, so let me just hit that. Ooh, do you know? Oh, do you know how to put sine squared in your calculator?
Yeah, the sign.
I need to put the sign. Yeah, are you guys getting it? I need to put the sign, and then I need to say, you whole thing need to be squared. Did you know that? You can't put the squared next to the sin. You got to put the squared around the entire sign. Sign of, square it. Don't square sin. There's a life lesson in there somewhere. Okay, so. Hey, it's over 400. Are we good? What about the poor people that said 14 to 16? Aw, they would have been bad. Remember, second back goes all the way back. Saves me time. I have 14 to 16. Guess what? Either one of you would have been fine.
You
Just go around the max, and then they're going to make sure it goes above. So all we need to do is give some 2-hour time interval. I can say 4. T within, you choose whatever one you want, but 13 to 15. The definite integral from 13 to 15 of L of T dt is equal to, I'm just using the first one that I saw, which was 431.931. 431.931. I would be double and triple checking my calculator, making sure I'm not writing anything wrong. Hopefully you guys are too. Oh, wait, cars. Is greater than 400. So what does that mean? Therefore. You can write the word therefore, or use the 3 dots and be a snazzy higher mathematician and be like, oh, that means therefore. Or you could be a logician also. Logician? Did you say that? Someone who studies logic? Anyway, philosopher. Therefore, the traffic engineers must install a signal.
Oh.
Because wasn't that the point of the project?
Why don't we just put everyone in the auto driving car where you just can just not install signal and everyone's still moving?
You're assuming that
I knew.
families will be able to afford a self-driving car.
It's not that expensive. In the future, it'll be cheaper and cheaper.
If you live in a tent under a bridge, Joe, it will be expensive. If you don't have enough money to buy like an actual meal every day, it will be expensive.
But
They also might not have a car, but some people live in their cars and aren't able to afford even a room to rent for the night. There you go.
That's sad, but
I know it's sad.
why would they
Okay.
like?
Anybody else need me to run around? Run around. Go pop into any other problems. I mean, I could run around through your packet, but that's kind of weird. Wait, nowhere?
I actually didn't have one.
Okay, yeah, which one? B? Okay, this one is a motionish one. Motionish one. We have 2 runners. Now here's the weird thing, guys. If I were you, I would make a point that I know that this is velocity of runner A. It's rate, but it's only rate of runner A. And then don't I have also rate
Of runner B is the.
of runner B? Yeah, is the equation. So I have 2 different things, and they love doing this, giving you a table for one, a graph for another, a function for one, a table of another. They love mixing up the notation. So, what's letter B asking?
Find the acceleration of runner A.
Acceleration, but acceleration is B prime. So I need to find acceleration of runner A. So I can find acceleration of runner A and acceleration of runner B. So wait a minute, acceleration of runner A would be the velocity of runner A prime. So then, PK, help me out. Is that the graph or is that the equation?
Runner A is the.
Ooh, okay. And then I also need to find the acceleration of runner B, which is the velocity prime of B. This one is the equation, right? Okay, so this one I can take the dt of my v of t at t equals 2, which I would love to tell you is a calculator problem, but sadly I'm pretty sure this one is not. But the question still remains, how do I know, wait, I don't want velocity. Now 7-ish would be the velocity, just to click towards the y's. This is a line, and we can make equations of any lines we need, which means 7-ish would not be sufficient, and you would probably get it wrong, because there is a precise answer. If they wanted velocity of 2. Pause. So for letter B, they don't want velocity. Velocity, what do they want? Acceleration is tangent line, aka slope, aka, rise over run. What's rise over run? Well, I see you going up 10 and over 3. 10/3 is the slope at that point. So 10/3 is this one, which is fairly easy. But what's going to be a little bit harder? Is it feet? Is it seconds? No, meters per second? Meters per second squared? What's going to be a little harder is actually taking the derivative with the quotient. And then you just have to say, indicate units of measure. Oh, no, they did. Bottom, you guys can go ahead and get going. I'm just going to stick it to the man. Bottom, D, top. Hey, and I'm plugging in 2 minus top, D, bottom, which is 2, all over bottom squared. As long as I've done it right, I can be done. Cheating, because cheating that will get me good points as opposed to dangerous, possibly bad points. Alright guys, I think in period 1 we did numbers. We did number 7 all the way. Same one you guys did. We did number 6 all the way yesterday, at least most of them. I think you need some brownies. Okay.